All right, good morning, good afternoon. Welcome to day 8, and let's start off with our bell work. I'm going to go through these pretty quickly because, as you know, today you do have a skills check. And hopefully by now this all is relatively well known and kind of like a review. So the directions say to factor, I need to look first as I see two terms for a greatest common factor. So I am going to divide out a 2, a x to the third power, which is the smallest exponent, and a y to the first power. And when I factor those out, I pull it out in front. And what do I have left? I put that in my parentheses. 2 divided by 2 is 1. X to the fourth divided by x to the third. You subtract. So that's x to the first, and y divided by y is 1. Plus 6 divided by 2 is 3. X to the third divided by x to the third simplifies out to be 1. Y squared divided by y to the first is going to be y to the first. And there is the answer for the first problem. The second problem I notice has three terms, and first of all, going through my paces, greatest common factor. Well, there is a 1 understood here. 1 is going to be the greatest common factor. That's not helpful. There is no x. This is not difference of squares. It is a trinomial. All right, so here I have a is equal to 1, b is equal to negative 12, and c is equal to 27. So I start with the x box, a times c at the top, which is 1 times 27, and b is negative 12. So looking for two factors of 27 that add to give me a negative 12, and that's going to be a negative 3 and negative 9. We could go on to the box part. And first term goes in the first box, x squared. Last term goes in the last box. And these two that we found times our variable x go in the middle. So greatest common factor here is going to be x minus 3 and x minus 9. So that is x minus 3 times x minus 9. Now, I have not told you yet, this part yet, but as you look at this, if your a value is equal to 1, and only if you have a quadratic, meaning x is to the second power on the first term, x is to the first, no x on the last term. If you have a quadratic trinomial where a is equal to 1 and a has to be equal to 1, I want you to take a look here, because your two factors that you found here were negative 3 and negative 9. If you look over here, you will see x minus 3, which that negative 3 minus 3 is the same, and x minus 9. So that is a bit of a shortcut, because then that takes out even having to do the box. So you would just say x minus 3 times quantity x plus 9. If you had something like this and a was equal to 1 and you ended up with a positive 4 and a negative 1, then that would be x plus 4 and x minus 1. But that is only if a is equal to 1. If a is equal to some other value, then it's not going to work that way. But I wanted to show you that little shortcut. All right, let's take a look at number 3. I have 3 terms. Looking for greatest common factor first, which I do have because I see they're all even. So I'm going to divide by 2 and come up with a new trinomial of x squared plus 8x minus 20. Now, as you notice, my new trinomial has a 1 here, so we can try that. No other greatest common factor. A is equal to 1. B is equal to 8. C is equal to negative 20. And when I'm doing this, A times C goes at the top. So that is negative 20 at the top. And B goes on the bottom. So factors of negative 20 that add to be 8. And because that's negative, I know that I'm going to have one negative and one positive, and the positive is going to go on the larger number. So I'm thinking 10 and 2, so that's a positive 10 and a negative 2, and that works. And because A is equal to 1 here, I can rewrite this as the first common factor that I found, 2, times, that is a positive 10, so it's going to be x plus 10, and this is a negative 2, so it's going to be x minus 2. And that saves you the time in doing the x box. All right, let's go right into our notes. And again, if you are watching this on video, you can play it back slower the next time. And keeping in mind we have a skills check today. This is a quick review. So the steps to factoring. Number 1, always remember to look for a greatest common factor. Unless you have 4 terms, then you're going to factor by grouping. But otherwise, look for greatest common factor. Number 2, check for a difference of 2 perfect squares. And that's what we just learned about yesterday. That is my favorite form of factoring. And number 3, if you have 3 terms, then you are going to use X box. Okay, so let's jump down to these examples. Factor the following polynomials. I have 2 terms. First, I'm going to look for a greatest common factor. So I have 16 and 36. They are both even, so I know 2 would work. Always start with your smallest coefficient. So I've got 1 and 16, 2 and 8, 4 and 4. 8 is a factor of 16. It is not for 36. I know 4 is going to work, so I'm going to divide by 4. 4 gets factored out in front. 16 divided by 4 is 4x squared minus 9. And here I see a difference of 2 squares. So that is going to be 4, and I'm going to rewrite this as 2, I was going to say 2 squared x squared. I think I'll do that for now. Minus, this is another perfect square, 3 squared. Come on. So 4 still stays out front. Since both of these are squared, when I take the square root, I would get 2x, which would be the square root, plus 3, and then 2x minus 3. And that is the factorization for the first problem. All right, looking over at B, It is a trinomial. So first I'm going to check for greatest common factor. I see they are all even numbers, so I am going to divide by 2. That means 2 is my very first factor, and when I divide, I get x squared minus 4x minus 5. All right, and now I'm going to do for my trinomial, my ABCs. A is equal to 1, B is equal to negative 4, and C is equal to negative 5. So in my X box, A times C at the top is negative 5, and on the bottom is B, which is negative 4. So 2 factors of negative 5 that add to give me negative 4. Because this product is negative, I know one's going to be positive, one's going to be negative, and the larger digit is going to be the negative one. So I'm thinking 1 and negative 5. 1 plus negative 5 is negative 4. And because A is equal to 1, I can simply write these out using these as they are. But don't forget, we factored out a 2 at the beginning. So that is 2 times x plus 1 times quantity x minus 5. And there is your factorization. Let's go quickly to letter C. It's a trinomial. They are not all even, and 2 being the smallest coefficient is not a factor of 5. So I can't factor anything out. No greatest common factor. So we'll go right to the X box. So A is equal to 2, B is equal to negative 5, C is equal to negative 12, X box, and here A is not 1, so I can't use the simple new factors that we find. We need to get to the box part 2. So A times C is negative 24, B is negative 5. Negative 24 tells me I'm going to have a positive and a negative, and the negative is going to be larger. So I am looking at negative 8 and 3. Again, because A is not equal to 1, we need to do the X box. Okay. So first box, first term, 2x squared. Last box, negative 12. Middle is 3x and negative 8x. So looking at the greatest common factor for each row, I see 2x. Over for the second row, I have a 3. For the column, 2 and 3, that is just 1x. And back here at the 8, negative 8, 8 is not a factor. The next highest factor of 8 would be 4. And because this first term in the column is negative, it's going to be a negative 4. So factorization here is parentheses 2x plus 3, which is right here, and 1x minus 4, which is right there. Letter D, I have 2 terms. Greatest common factor, look at your smallest coefficient, 6. Obviously is not a factor of 9, but 3 is. And an x. I can take out an x from both of those. So when I factor that out in front, and after dividing, I see I have 2x left plus 3. That's the prime factorization for that. Oop. All right, we're getting close to the end here. Down here, I see a trinomial. A is equal to 1, so I'm not going to have a greatest common factor. So A is 1, B is negative 7, and C is negative 18. Do the X box in the top. 1 times negative 18 is negative 18. B is negative 7. Two factors that multiply to give negative 18 and add to give negative 7. A positive and a negative factor, and the negative is going to go on the larger number. So I'm looking at negative 9 and positive 2. And because A is equal to 1, I can simply write this as X, or whatever your variable is, plus 2, because that's a positive 2, and X minus 9. And finally, we have the last one, 9x squared minus 25. Looks like a difference of 2 squares, but I need to check to see if I have a factor that can divide out first. Smallest coefficient is a 9. So factors of 9 are 1 and 9. 9 is not a factor of 25, and 3. And 3 is not a factor of 25. So I rewrite this as 3 squared x squared, because 3 squared is 9, x squared is x squared, minus 25. I can rewrite that as 5 squared. I could also take this one step more and say this is the whole quantity 3x squared minus 5 squared. Okay? And that way the squared would go for the 3 and the x. So when I take the square root, this is the difference of two perfect squares. If you take the square root of something to the second, it is whatever was raised to the second power. So that is going to be first term 3x plus 5, and the last term 3x minus 5. Okay, and that's the factorization. Hope this has been a good review. Go and pick up a skills check from Mr. Hart and get started on that right away. Good luck with the skills check, and I will see you back on Tuesday. Have a great rest of your day.